Hello everybody, so this video is how to update a dictionary within a for loop, and it's also within a while loop, but that's beside the point for the purposes of this. So what I have is a board. Now Maxime, CodeMonkey King, before problems started, he helped me with an idea I had for a board game. Now the board that I was creating was using a two-dimensional array, and Maxim said it would be much faster. Obviously, he's got much more experience of making board games. He said it would be much faster using a one-dimensional array. So if you're looking at the screen rather than looking out the window, um, this is the board. So I don't want to reveal what the actual game is just yet, but rest assured that it's similar to a chessboard. What we've got is actually, if you see the zeros here, we've got the board representation showing 5 rows and 8 squares in each row. The minus ones around the outside represent the edge of the board or outside of the board. So it helps with our computation of what squares we actually can play on and make moves on. The problem with this is if you're used to using NumPy, Pandas, Excel even, you'll be used to working with rows and columns. And to create rows and columns from a one-dimensional list without using another module package, this is how you need to do it. I'm not saying this is the best way, but this is the way that I've worked out how to do it. So we've got some constants here. So width is 10. So obviously create these as constants just in case you ever want to modify the game at a later point. The internal board representation, obviously you would have to manually change. But for the rest of the code, if you work with constants, then it's going to make it more modifiable in the future. So width is 10. Now 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. They're all 10, but it's obviously they look less when there's a load of zeros because the width of the zero is less than the width of the -1 when it's being displayed. So even on this row, you can count. There we go. That's 5 plus 5 equals 10. So we have 10 columns wide and 7 rows height. So width equals 10, height equals 7. So the total number of internal board positions is actually 70 in this game. Don't confuse this with chess or anything you've seen on any chess program, because this is not going to be chess. This is going to be a different game, which you will find out eventually once I've written the code for it and taught myself how to use Negamax or Minimax algorithm. That's for another day. This video is just actually showing how you can, well, I'm actually going to be doing it in JavaScript, so I will have to adapt this code to work with JavaScript, but that's beyond this video. This is really just testing the algorithm and just testing the core approach to solving the problem in Python. Square equals 0. Where did I use square? Square is actually the internal board representation. No, it's not. It is, where did I use it? Here. So square, what I'm doing is I'm looking to see if this is the actual playing board. So square is actually the internal playing board, and then we'll get to square again in a minute. If board square is greater than 0, then I'm adding to the tally. So actually, no, square is the actual index of the list. So I've got a list effectively with 70 items, and as I progress through the list, checking the list, it will use that index. Tally, right? Tally is what we want. So this is ultimately, as you can see in the bottom left of the screen, I've got it working. So we'll get to that in a second. So the problem is when you iterate through rows and columns, it's always doing effectively it's doing a row by row by row, and then it's checking each column. Now, what if you instead of check it, so to check a column, to check if a row was all ones, that would be fairly trivial. But to check if a column had some ones in it, so the one actually represents a player's piece in the game. So you can see, I've just for testing, I've put in a 1 here, a 1 there, a 1 there, 1 there, and 1 there. This is just to simulate the game in progress. So when I've highlight 1, VS Code is also highlighting all of the -1s as well. Sorry about that. But yeah, you can see I've got on line 5, I've got 1, 0, 1, 1, and on line 6, I've got another 1. So this is me simulating some plays within the game. And then what I'm doing is I'm just saying so we're going to iterate through every square on the board. So while square is less than total -1, and total we know is 70. And the reason why I'm keep doing a -1 is because once you don't want it to go past the end. So for I in range height, so we're going to say the outer loop is going to need to be to iterate through the rows. So height equals 7. So we're going to do the outer loop 7 times to go through these 7 lines. Now, we're treating this one-dimensional array actually as as rows and columns. So this is the whole difficulty of what we're doing here. Anyway, for I in range height, so we're going to do it 7 times. Then for C in range, to be honest, I should change that to R, shouldn't I? For R, let me just change that there. That's better. Yeah, for row in the height, check the columns across the width, and this is just me printing to the screen for testing on line 21. Right, we're getting to the good bit now. What I needed to do was read across each, go for each row. So starting at row, effectively, the first row that we're interested in is actually here. So okay, so it's selected all the zeros. Right, so the first row, we want to go for all the row and we want to check for a number 1. So what we do is we say if board square, so square is actually the index of the one-dimensional array. So board, so if the current square, if the value on the current square is greater than 0, then what we do is we say tally, and then C is actually the column, and column we want to store in a dictionary. So we're going to have this tally dictionary, which I've written just for kind of ease of understanding, ease of writing the code. We've got 8 columns, so each key in this dictionary is a column. Now, as we iterate through the big while loop, what we're going to do is go through each row, and then as we go into each row, we're then going to go across the row, and then we're going to update the tally. So the tally dictionary is going to have its C value updated. So C is the current column, and the current column is actually a key in the dictionary. So hopefully that makes sense. This took me a while to get going, so I'm kind of showing this in case anybody's ever come across this before, where you're actually trying to read rows and columns from a one-dimensional list, or one-dimensional array, as you might call it in other languages. This is also the important bit. So we're going to update. You can't just do, if you do tally square bracket C plus equals 1, you'll get an error. And if I show you, I had that earlier, much earlier. In fact, there we have. If you do tally get C plus 1, you get the none type. So tally C, so the column, what you want to do is update the value of the column key. So the column key is actually the 0 column. So although that's numeric, it's actually the name of the column. And then we're going to add 1. And then this is where we add 1. We add to the square here. So what we do is if the current square plus 1 is less than 70, then we're going to add 1 and move on. So this is what actually helps. This is what iterates through the while loop. So hopefully this makes sense. Feel free to copy it, experiment, play with it, break it. I'll put a link to the code below. So really, this is not a living program as such, but it's a concept and it's an idea and it's an approach to solving the problem of iterating through rows and columns which don't actually exist other than to a human, if that makes sense. So what we've got is we've got a while loop, we've got 2 for loops, so one for the rows, one for the columns, and then as we read through the columns in a row, we then update the dictionary with the tally. And at the end, let's run it. So if I'll just Control L, clear, and then run it. And there we have it. So this is actually showing what's going on. And so for the first row, it was all -1. So what it was doing was reading that row. Then it read this row. Sorry about it's highlighting several. So line 3 is on line 3. Then on the next row, that was the row 1. Row 2, 1 with all zeros. Row 3, so the row 3 is actually row 3 of the board as we look at it, because row 0 was actually off the board. So row 3 is actually row 3 as we see it, so it's this row. And you can see we've spotted that row 3 column 2 has a 1 in it, row 3 column 4, column 5, column 6. So it's spotted that these, we've got a 1, and then we've got 3 1s there. So that's those 3. Good. So hopefully that's made it clear as to what we're actually doing. We're iterating through, going through a while loop which iterates through 70 squares on a board representation. We then loop through the rows, then we loop through the columns on each row, and then we update a dictionary with the values for each column. And this is how we can tally up which column has the most values in it. So when we get to, we're looking for, I've called it, printed it out as best column, and you can see that the best column currently is column 4 with 2 values. So let's just change this. So if I put a 1 in there, Let's just change that to a 1 and a 1 there. So now, just we as a human, we can read this and we can, although it's not a column, it's a list, a one-dimensional list, but to a human, we know that it's a column, and we know that, so -1s are off the board, so that is column 1. So column 2 should be the best. So run it again, and there we see best column. So nothing in column 0, nothing in column 1, column 2, which 1, 1, 1. Column 2 has 3 vertical, so 3, the value 3. So although this might look quite hard work or convoluted, so if you're used to make an internal board representation as a one-dimensional list because it's quicker, then this would be put into a function, and you would probably call it check best column or something. And for those of you who are used to writing board games, this is probably really obvious, but I just thought it would be good practice to understand that you can count through and tally up a column rather than tallying up a row, because a row is quite simple, but a column not so. So thank you for watching. I'll put a link to this on GitHub. You can have a copy. I'd recommend just playing around with it. I'm going to continue to play around with it because yeah, without this line 21, you'll get really confused. So, and also remember that row 0, the first row and the last row won't appear on the actual board that you see, and the same for column 0 and the last column. So yeah, thanks for watching, and hopefully I've confused you, given you something to think about. Copy this off of the link in the description. You can play around with it, and yeah, why not write a board game? And yeah, just before I go, just if hopefully eventually Maxim will get back to YouTube, and in the meantime, can you just yeah, watch as many of Code Monkey King's videos and chess programming videos on his chess programming channel as possible. And YouTube revenue's not immense, but as one of the supermarkets says in the UK, every little helps. So yeah, thanks for watching, and I'll be back soon. Hopefully I'll adapt this to work in JavaScript, and I might even show you what the game is, but no promises there. Thank you.